Hello students, welcome to today's session of chemistry. As you all know, we have started study of 7th lesson of your syllabus, that is modern periodic table. Before starting today's session, we will just revise what we learned in the previous session. In the previous session, we learned about the periodic trends in chemical properties. And the properties we discussed were valency and the second is metallic and non-metallic character. So what we learned about the periodic trend in valency. Valency of the main group elements is usually equal to the number of valence electrons either, or it is equal to the difference between 8 and the number of valence electrons. And across a group, it shows a gradual variation. Across a period, it shows a gradual variation because the atomic number increases from left to right. Second property we discussed, and that is metallic and non-metallic character. Metallic character, about it, if we say it increases down a group, while it decreases across a period. Why? Because ionization enthalpy, it decreases down the group and ionization enthalpy increases across the period. And non-metallic character, it increases across the period and decreases down the group. Why? Because electron gain enthalpy becomes more and more negative across the period, while it becomes tend to be less negative down the group. Now, in today's session, we are going to learn about the periodic trends in chemical reactivity. Dear students, this is a last session and this is the last part we are going to discuss. Now, according to you, what is chemical reactivity? Chemical reactivity of elements is decided by how easily it attains electronic configuration of the nearest inert gas by gaining or losing electrons. Now, what is chemical reactivity according to the definition? How easily an element attains electronic configuration of the nearest inert gas. We know about octet rule. That means in the valence shell, there should be 8 electrons to attain stability. Exception is the first shell where 2 electrons is enough. Now, to attain that octet, what is the way in front of those elements? Either they can lose electron or they can gain electrons. And hence, anyhow, the element in the nature tries to achieve stability by gaining 8 electrons or the electrons same as that of noble gas near to them. And if they achieve that electronic configuration, the stable electronic configuration, then in that process they form a compound or a molecule. Anyhow, and thus the chemical reactivity depends on this, how easily they achieve this ability. Now, the ways we decided were the same, by gaining and by losing the electron. Now, which elements gain electrons and which elements have a tendency to lose electrons? Those we can say by observing the periodic table. Now, the elements preceding an inert gas, preceding, that means before inert gas, that means group 16, 17, like that. Those react by gaining electrons in the outermost shell. That means they have a tendency to gain electrons. Why? Can you tell me that? Because if we see the general outer electronic configuration of 16 group or 17 group, it is Ns2Np4, Ns2Np5. That means they require either 1 or 2 electrons to achieve the octet. Hence, they have a tendency to gain the electrons in the outermost shell. Whereas The elements which follow an inert gas follow that after inert gas. If you see at the periodic table, there is nothing, no group is there after inert gas, then which one is the group which follow inert gas? That is group number 1, alkali metals. Consider this periodic table. If it is circular, then periodic, suppose noble gas or 18th group elements are at the center, then preceding group will be halogen and the following group will be alkali metals. Understood? So the first group or alkali metals are following inert gas elements, and those elements have a tendency to lose valence electrons or to donate valence electrons to achieve stability or to achieve the stable electronic configuration as that of the inert gas. Why? There are so many reasons behind this process, because all these processes are naturally occurring. So, understood? 17th group, 16th and 17th, we can say those groups have a tendency to gain electrons, while first, second, third group, they have a tendency to lose the electrons. Now, the chemical reactivity, thus, it is decided by two enthalpy values. Which are those? Electron gain enthalpy value, and second is ionization enthalpy values. And these two values, they are dependent upon two elemental properties like effective nuclear charge and finally the atomic size. So, up till now, we learned about the periodic trends in elemental properties, physical properties, and chemical properties. And all these properties are related to each other, and all these properties together decide the chemical reactivity of the element. Now, the ionization enthalpy. Suppose we take first value. Ionization enthalpy values, do you remember? They are smallest for the first group element, that is alkali metals. So these are smallest for the element on the extreme left in a period. What about electron gain enthalpy? These values are most negative for the second last element on the extreme right. Second last, why? Because those are halogens. We are not going to consider about the inert gases because they are non-reactive. Now, second last group, that is halogens, they have highest negative electron gain enthalpy values. What does it mean? Negative electron gain enthalpy, negative, that means energy is released when an electron is added. Now, the electron gain enthalpy values are most negative, that means they are eager to gain the electron to achieve the noble gas configuration because they require only one electron. So, these two values, ionization enthalpy and electron gain enthalpy, decide the chemical reactivity. But as I told you, these values depend on the effective nuclear charge and finally on the atomic size. That means effective nuclear charge, if we say, it increases across the period and decreases down the group. What about atomic size? It decreases across the period, increases down the group. Those also we can relate with this chemical reactivity. Now, the most reactive elements in the periodic table, where are those? Those are located to the extreme left, that is alkali metals, and to the extreme right, that means halogens. These are extremely or most reactive elements in the periodic table. Now, two more properties we discussed in the previous session, metallic and non-metallic character. So, those also decide the chemical reactivity. But one more property is there which we haven't discussed up till now, and that is the reaction of elements with oxygen to form oxides. And the nature of oxides also decides the reactivity of the elements. That means up till now we discussed about the elemental properties, physical properties, chemical properties which decide the chemical reactivity of the element, and that discussion told us that the alkali metals and the halogens are the most reactive elements in the periodic table. But one property, that is formation of oxides, and the nature of oxides also decides the reactivity. Now, The reactive elements on the extreme left, suppose we take an example of alkali metals, they react easily, vigorously. That means the reaction is very strong. They react easily with oxygen to form their oxides. And these oxides are strongly basic oxides. Why? Because take an example of sodium. Sodium forms its oxide like Na2O, which when treated with water forms strong base like sodium hydroxide. So, as it forms strong base, this oxide is a basic oxide. So, all the alkali metals, they form oxides easily, and these oxides are basic in nature. We will take example of the elements on the extreme right, that is halogens. They also react with oxygen to form oxides. For example, oxide of chlorine, that is Cl2O7, which on reaction with water form strong acid like HCl4, hydrochloric acid. It is not HCl. There are variety of acids chlorine oxide can form, out of which one is HCl4 and which is strong acid. Now, these these oxides are hence acidic in nature because they form acid on treatment with water. So, extreme left, that is alkali metals, form basic oxides, while the elements on the right, that is halogen, forms acidic oxide. Then, what about the oxides of the elements at the center of the main group elements? Main group elements. We are going to consider only main group element, that is group number 1, 2, and then 13, 14, 15, 16, and 17. Inert gases are also there. We are not going to consider about D block and A block elements. These are transition elements and inner transition elements. They are not so much reactive as that of main group elements. So, we will discuss about their reactivity also, but later. Now, the elements in the center of the main elements, they also can form oxides with oxygen. For example, if we take aluminium, which is in the 13th group, aluminium forms oxide and which is amphoteric in nature. Do you know what is amphoteric? Amphoteric, that means that oxide can be acidic as well as basic. How we decided that that oxide is acidic or basic? We treated that oxide with water. If it forms base, then it is basic oxide. If it forms acid, then it is acidic oxide. But aluminum oxide can form base as well as acid on treating with water. Hence, aluminum oxide is amphoteric in nature. Some oxides of the center of the main group elements are neutral, like carbon monoxide and nitric oxide are neutral oxides. Why they are neutral? They are neither acidic nor basic. They can be weakly acidic as well. For example, carbon can form two types of oxide like carbon monoxide as well as carbon dioxide. Carbon monoxide is neutral, but carbon dioxide on treating with water forms H2CO3, that is carbonic acid, but carbonic acid is a weak acid. Hence, these oxides can be weakly acidic. So, do you understand by this? That means alkali metals can form basic oxides, halogens can form acidic oxide, and while the center, that is 13, 14 group elements, they form either amphoteric oxides or neutral oxides or weakly acidic oxides. Now, what about transition and inner transition elements? Now, if we consider all the groups, that is those transition element, they have 10 groups. So, all the groups, if we go from left to right, then there is no much change in the atomic radii, and hence they the inner transition elements also have same problem. There is lanthanides and actinides. There are two series. Say they have very less change in the atomic radii, and hence the transition metals and inner transition elements which are belonging to the individual series have similar chemical properties. No much change is there because in a D block we have seen there are 4 series, while in the F block there are 2 series. If you go across the series from left to right, individual series, there is no much change, hence there is no much change in the chemical properties either. If you consider the ionization enthalpies, those are also in between that of S block and P block. Hence, they almost show similar chemical properties, which the elements in the individual series, they show almost similar chemical properties. Understood? So, students, here is the end of the lesson, modern periodic table. What is today's assignment then? I have given you 3 different oxides: lithium oxide, carbon dioxide, and boron oxide. You have to find out which oxide will be the most basic, which will be the most acidic, and which oxide is amphoteric. Only this much. Find out it. Just see which group they belong and you will understand which one is acidic, which one is basic, and which one is amphoteric. Understood? Now, we will just revise or take a look back on this lesson. We have started this periodic table lesson by observing the periodic table. Most of the time, the question to draw the skeleton of the periodic table can be asked in the exam. So, you have to draw the skeleton where you have to show in detail about the groups and the periods and the blocks, everything. Then we learn about the electronic configuration in groups, then in blocks, then in the periods. Again, we have seen in detail about the block-wise characteristics of the elements, that is characteristics of S block, P block, D block as well as A block elements. And then we started study of periodic trends. In periodic trends, we learned about the periodic trends in elemental properties, in physical properties, and in chemical properties. Which are the elemental properties we learn? That is effective nuclear charge, screening effect, and atomic and ionic radii, or atomic and ionic radii belongs to physical properties. Elemental properties are those effective nuclear charge and screening effect. So, effective nuclear charge, what is it? How it changes? It goes on increasing across a period, goes on decreasing down a group. Like that screening effect. Screening effect, as we move from left to right, what happens to screening effect? The sigma sign, which is there for screening effect, and screening effect, as we move from left to right, the screening effect of the core electrons remains same, while down a group, that screening effect goes on increasing because every time a new shell is added. We learned about the periodic trends in physical properties, in which we learn about atomic and ionic radii as well as ionization enthalpy. Now, if atomic and ionic radii, the atomic radius increases down a group, decreases across a period, because down a group a new shell is added. While ionic radius shows same effect, in which we learn about the anion as well as cation. Ionic radius also, it decreases across a period, increases down a group. What about ionization enthalpy? It is the energy required to remove an electron from the outermost shell, and it goes on increasing across a period and decreasing down a group. Then we learn about the electron gain enthalpy. That is also the physical property. Electron gain enthalpy, the enthalpy change that takes place when an electron is added to the valence shell. And electron gain enthalpy becomes more and more negative when we move across a period, and it becomes less negative down a group. Then we learned another physical property, that is electronegativity. It is the ability of a covalently bonded atom to attract the shared electron pair towards itself, and electronegativity values increase across a period and decrease down the group. Then we learned about the periodic trends in chemical properties. Chemical properties in which we discussed about valency as well as metallic and non-metallic character. So that we discussed at the start of this session. Now, lastly, all these properties, those directly affect chemical reactivity of the element, and that we discussed in today's session. So this is all about modern periodic table. Students, we are going to start with next lesson, that is eighth lesson of your syllabus in the next session, and that is elements of group 1 and group 2. Thank you.